grad Nike und New Power, doch das macht mich nicht zum Rapper. Das gibt mir nur die Pressure, um so ein Vielfaches besser.
Welcome back everyone, I'm Mohammed Rakib from ExploI.T and hope you are all doing good. So by now you know how IPs are assigned to a node using the DHCP services in the network. But for sending a message or anything from one node to another node, we must need 4 addresses of the network. These addresses work in conjugation to send a message from one node to the other nodes. So these 4 addresses are a vital need to send messages or even a single ping message from one node to another node in the network. These are the sender's MAC address, the sender's IP address, the receiver's MAC address and receiver's IP address. So these 4 are the sender's IP and MAC address and the receiver's IP and MAC address. So if you know the IP and MAC address of your computer and if you know the IP and MAC address of the destination computer, you can ping from your computer to the destination computer. These addresses, if available, helps in communicating across the other nodes of the network. Now let's take a look at example here. So I'm back at Cisco Packet Tracer and this is a PC2, that is a device that is connected to the switch, and then we have PC0 connected to the same switch. So now I'm inside the same network and I need to connect to this PC0. Go to desktops and then command prompt, and then inside the command prompt, as I told you that you must know 4 of those addresses so that you can send the messages from one node to another node. Now let's check, do I have 4 of them or not. I'm checking for my addresses. Do I know my addresses? Okay, so my IP is 10.0.0.3, so I know my IP address. And what is my MAC? Let us see, IP config/all. What is this? Okay, space issue. And then where is my MAC address? Okay, and then I have my MAC address, that is 000196BE9788. This is the physical address of the link layer address. Okay, so this is my MAC address. You can also see it here in the physical, or if I hover over this here, you will see the MAC address 0001.96BE and then 9788. So this is my MAC address. So if I go to this programming, sorry, not desktop, so this is my MAC address. But I do know my MAC address and I do know my IP address. So IP address 10.0.0.3 and the MAC address is this. From this PC2, this is me. I wish to ping PC0, that is the sender. So do I know the sender's IP? Yes, I know it. That is ping 10.0.0.1. I know this because I have set up this environment. Now let me check. Desktop and then IP config. Okay, 10.0.0.1, this is the same because I have set up, I remembered 10.0.0.1, so I know the destination address, that is 10.0.0.1. So by the time I run this command, that is ping 10.0.0.1, I know 3 addresses. My IP address, that is 10.0.0.3, my MAC address, that is something with 78, ending with 78, and the destination IP address, that is 10.0.0.1. So if I don't know the MAC address of the destination IP, and I cannot send message without the last piece to the puzzle, that is, I must know all of them, the 4 of them, to send a message to the destination. But at this moment I know just 3 things: my IP, my MAC and the destination IP. Now let's hit enter and see if it works or not. And yes, you see that the messages have been sent, and in turn the messages have been replied to. I was able to send message to the destination, and moreover the destination also replied back to my messages. And how is that possible? I just told you that you need to know 4 of them, but with only 3 of them I was able to send messages to that. So how is this happening? Am I saying something wrong? Let's see how this works. Now back to the address resolution protocol. In this case, I knew 3 out of 4 addresses. My IP, my MAC, I know it. Your IP, that means the destination IP, I knew because I set up the environment. For example, let's suppose you want to ping me. Let's assume we both are in a Cisco Packet Tracer environment and you want to ping my device. Okay, you know your IP, you know your MAC address, and you know my IP. 3 addresses are enough to send me a ping message. But what about the 4th one? The 4th one was mandatory to provide, and from where it came. Let us see where it came from. It came from this address resolution protocol, or the ARP protocol. The work of this ARP protocol is following. This protocol maps an IP address with a MAC address just like a DNS, but more specifically it maps a layer 3 address, that is the IP address, to a layer 2 address, that is a MAC address. So by layer 3 address, you can extract a layer 2 address with the following ARP protocol. That means if you know the layer 3 address of a node, which is commonly known as the IP address of a node, the ARP can automatically fetch the corresponding layer 2 address or the MAC address from it. And also, as we learned in the Cisco packet tracer examples in the previous sections where I showed you how devices works in actual, you saw when we went to the simulation mode, the very first message that was sent was ARP message. ICMP was there, but before that there was another message that was the ARP message. Okay, the main job of an ARP address is to find the corresponding MAC address of the node to which we want to send a message to. So its main job is to find the MAC address or the layer 2 address of a device of which it knows the IP address. Once the ARP message finds the MAC address that is associated to that IP address, it tells the user the MAC information is found, and the user can use that information, send the message to that node. So this is the job of the address resolution protocol, and it is self-explanatory. It resolves the address, and hence it is known as the address resolution protocol.